Welcome back, everybody. Got a little bit of a different video for you today. I think it falls under the same category as the pop-up headlights, even though we're not actually working on the pop-up headlights in this video. While we were under there doing the 3D scans of all the front end of the car, I tried to install this guy, the ram air intake, which was technically for a Focus ST, and it didn't fit. So since it didn't fit, I was already this deep, I already got all the scans, I figured I may as well take a crack at making my own. I've posted a handful of times in the Focus RS Facebook group, and there's actually been a lot of attention and a lot of really good positive feedback, mostly. And so I started designing my own. So this video is going to be a lot of CAD and me just kind of talking over it. All of the CAD that I'm going to do, all the time lapses, I'm doing at 400 times speed. So if you really care to see all the CAD and all the buttons I click and everything, if you go to YouTube and you click on the 0.25 speed, you can watch it in real time. That way, if you want to see my workflow, you can, and everybody else doesn't have to be bored by my hours upon hours of CAD to get through this. So let's get rolling into those time lapses and see how we go from nothing, just a scan like this, to the finished product like this. And go. So I found when you first start a 3D scan, you can actually go into the scan, the mesh body, and you can, it's called direct editing in Fusion. But when you do that, that lets you select the face of the mesh. So as you saw just a second ago, I went through and made 3 planes through 3 points on the mesh itself. And then I was able to pick one of those planes and start doing the sketch that I'm doing right now. Now there are ways to be more precise with your 3D scans and getting your bodies to line up perfectly and using the actual data. But honestly, I've found that it's just as easy to kind of eyeball it, get the hole centered where the scan file actually has a hole. And then if you just know what bolt goes there and you pick the appropriate standard hole diameter for whatever fastener you plan to use, you can get really close. And I'm accepting that I'm probably going to go through 2 or 3 printed iterations in order to get this right. And typically when I start my, making my bodies based off of scans, I like to kind of get a block, a rough shape, and then I slowly start sculpting it, less so designing it appropriately with a bunch of properly constrained drawings and work from precision. Do a lot more eyeballing and, as my boss would say, a little bit more of a maker in this situation and less so a machinist or an engineer. Now what you didn't see, because I cut it out because it was really long and boring, was me playing with the geometries to make that perimeter around the opening the same all the way around. It took a little bit longer than it should have because I dimensioned the drawing stupidly, but it's all right, we got there. Now I'm going through and I'm going to make the lofted plane for the downturn of the trumpet, as I've been calling it. So now I'm going to be going through and I'm going to be adding a cross point on each face that I want to loft from. So from those points, I can make an axis, and then from that axis, I can make a plane for me to edit off of. And then off of that plane, I now have two intersecting points on those faces, and now I have a rail that I can use for my loft to get it to go in the direction that I want. And then by simply subtracting one loft from the other, I get my shape. So now that I have the downturn for the air intake, I'm working on making the trumpet part, which is the mouth of the air intake. And I'm going about this kind of the down and dirty way initially. I'm going to try to do a lot more complicated lofts and make it really pretty and well swept. But I played with it for a while and I was just getting tired of messing with it. So this is the down and dirty way that I've found to make my inlet geometry to begin with. So I started by making a plane at an angle and then an offset plane. And now I'm going to go through and split the body through that plane and then play with the height of that plane and a little bit of the drawing geometry to get it to cut where I want it to. And this will give me at least a good starting point for the body. And to wrap it up, to make printing easier, as you can see, I'm cutting it in half in the center, and now I'm making a little interlocking feature for the two components. This way, when I print it, both pieces will just go vertically up, as opposed to having a bunch of support structure needed for overhangs and stuff like that. And as you see right here, there's actually a function where if you go into File, you can 3D print as the type, and it just lets you easily export as STL rather than having to go File, Export, and choosing your file paths and all that stuff. So it's just a lot easier of a workflow to get through. And here we are in Orca Slicer. If you're not using Orca Slicer, in my opinion, I think you're doing it wrong. Mostly because you can control multiple printers and not just Bamboo printers, as I have a couple Creality printers as well. But I mean, the Bamboo Lab X1 Carbon just does such a phenomenal job. This was my first try at getting the print out of ABS, and it went flawlessly. So I've actually got my two prints right here. It's pretty exciting. They came out really good. They're really, really strong. I did like 6 walls and 15% infill. It's really strong. I have no worry about the strength of this. And based off of the CAD and the stock part where the intake for the RS is, it looks like it'll slip right on, and I'm very excited to get this mounted in the car. Unfortunately, that's not going to be in this video. It'll be in the next one, or whichever subsequent one is when I finally get the car back up on the lift and get the front clip off. Trying to be sooner rather than later. But for now, thanks for hanging around. I'll see you in the next one.